All right, this is Aaron Holmberg from Corvallis Middle School in Corvallis, Montana. And today this video is going to show how to use the array model to understand the distributive property and solving a multiplication problem. Right in the very beginning, we want to say that there are three reasons why students need to study the array model and why we pick it out. Students need to visually and mentally solve multiplication problems. We want students to be able to think and do math in their heads, and the array model helps them train their mind for that. It also shows why the traditional algorithm works. When I say traditional algorithm, I mean doing math like this. This is the traditional algorithm, and we know the steps in that. It produces these partial products down below when we sum it up. That right there is the same thing that's going on in this sort of work, and the same thing that can be shown in this. So we want students to understand why this works. We don't want this just to be a trick they rely on and they don't know what it means, but it works. That's not good enough. The third reason is that the distributive property is a fundamental property of math, and it's something that they will continue to build on throughout their math career. So in this space here I've got a rectangle, and I'm going to be showing how to solve 17 times 14. Now of course eventually we want students to be able just to do this. Maybe they can even do it in their head, but certainly they can do it on paper. But this sort of thinking is what's behind it, and we want students to be able to do this too, because this is higher math. Leads to higher math, you say. Okay, so we have this rectangle here, and I have the factors 17 and 14. 17 appears to be a little bit larger, so I'm going to pick the larger side. 14 is down the side over here. Now, if this could be 27, and this could be 24, or this could be 37 and 24, or whatever. But the main thing is you want to kind of make it visually similar to the two numbers. So 17 is across the top. I'm going to draw a line here. This is called a partition line. And I'm going to draw a line here, and these lines approximate the idea that this is a distance of 10 from here to here, and this is a distance of 7 from here to here. Similarly, down the side we've got 10 and we've got 4. And what's going to happen here now is we have each of the different partial products. So the area of this piece of the larger array is called a partial product. A product is when you multiply two factors. So the answer to a multiplication problem is a product, and partial products is one of the four parts. So the first one we have here is 10 times 10. This is a 10 by 10 space. I'm not going to draw 10 columns of 10 rows and 100 squares. We're done with that by this age. The next one here, if I did 10 times 10, I'll just draw a real light line there. 10 times 10 is here. Well, the second one I'm going to go to is 10 times 7. It's over here. So this is 10 times 7. Down below, similarly, I'm going to multiply this factor by that one, which is 4 by 10. And if you notice, I'm always keeping the number that's on the left, 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 on the left. 4 is going to come first over here. I'm not going to switch it and do 7. Sometimes students will do that. They'll switch those numbers, but to do it in an orderly way, to not forget what's going on, you really should say 4 comes first because it's come first over here and it's first and it's first. 4 times 7 is up here. Okay, so now we have we're about to make the partial products from these expressions. I'll put parentheses around them so they resemble the problem down below. 10 times 10, of course, is 100, and I like to teach students to circle the area like that so that it stands out. 10 times 7 is 70. 4 times 10 is 40, and 4 times 7 is 28. Okay, and when I add those up, I can do it in my head. I could say 40 times 70 is 110, or 110. This is 210 plus 28 is 238. And that's the same work that I'm going to get down here when I solve it here. And with highlighters, I'm going to show you how all of this stuff up here is in this space, but it's also in this space over here. Okay, so I'm going to write 238 here because that is the total, and I sometimes teach students to double circle it because it tells me that they see that this is the total product. Okay, so breaking this down here. In class, we're going to do things like this. We're going to go 10. If this is 10 over on this side, then this is 10 over on this side. If this is 4 over on this side, then this is 4 on this side. 10 up here, 10 down here. And the yellow, I hope this shows up. 7 and 7 of those lengths, so that they can see that each of these are kind of translating across. Okay, so the first one here, this 100, well, I should back up a little bit. 17 times 14 is sitting right here on the bottom. I wonder if I can get all of this on one screen for you. There we go. And what we're going to do is we're going to see here that we've split the 17 into 10 and 7 just like we did above, and the 14 into 10 and 4 just like we did over here on the side. And the next step resembles FOIL, if you think about that from high school, first, outer, inner, last. So what's happening here is you're going to multiply one of the factors from this set of parentheses to this side. So it really means we're going 10, I know, I'm going to go like this for you. I'm going to say we're multiplying 10 times 10 right here, and that makes this 100. I'll just go ahead and color that to make it kind of visible for you. Then we're going to multiply 10 times 4, which is the same thing as 4 times 10, and so that one's right there. Now we're going to take the other term, and we're going to multiply it against both of these. So 7 times 10 is 70, and that's right here. It's getting kind of messy here, but we'll follow it. And 7 times 4 is the last one, and it's right down here. It's the 28. So all of the steps right there that we did above are in this kind of mechanism here. And again, this is why we've been learning the distributive property. That's the distributive property with two terms inside of those parentheses. Okay, so the next step is to sort of simplify it. 10 times 10 is written right here. So I'm going to underline each of those parts. 10 times 10 is the green right there. 10 times 4 I did in blue, or 4 times 10, and just reverse it, same thing. 7 times 10 was the pink up above, and 7 times 4 is the last one. So that's just showing the step that we did in our head, and I'm always saying that it's equal over here to the original multiplication expression.